again, it's Derek from Tomcat Gas Training and welcome to this video on what's inside a gas boiler. But before we get into this video, please could you take some time to subscribe because it helps the channel, and don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. Remember, Mondays and Wednesdays. All I've got left to say now is, let's get on with it! Now, this video is going to cover a few things. First of all, we're going to see what's inside gas boilers, and then the second thing is we're going to look at the progression of boilers, how boilers have changed. So we're going to be starting with this little thing. We're also using one manufacturer. We're going to be using Baxi, because I've got quite a lot of Baxis here, and they do show a progression in how boilers have changed. Now, Baxi was formed way back in 1866 in Preston by Richard Baxendale, hence the name Baxi, and they started off as an iron foundry. Then they went on to make heat exchangers and boilers. So they are now part of the BDR group, which is one of the biggest manufacturers of boilers in the world. So, as I said just a minute ago, let's get on with this video and let's find out exactly how boilers have progressed, and we'll look at this boiler first. Now, this little beauty here is a Baxi Bermuda, and the Baxi Bermuda came out in 1966, the year before I was born. So it's been going a few years then, but they had to cease production of these in 2005 when the condensing laws came in, and between 1999 and 2004 I was fitting a lot of these boilers for Manchester City Council around the Manchester area. Now, this is one of the later boilers, and you can tell that because one, it has a lot of electrical wires to control it. It's got a miniature little PCB under here. It's got the sniffer tube, so it's got electronic ignition, which the older ones just had a pilot light. So to make it more efficient, they gave it electronic ignition. But there is another way to tell how old these boilers are from Baxi, and that's by looking at the data badge. Now, a lot of manufacturers use the data badge to date them, so let's have a look. Now, from the data badge of this Baxi Bermuda 57/4M, we can't really date it that accurately because they changed the way they did the data badge and the date on them, Baxi, in 2003, and this boiler ran from 1996 to 2002. Now, I do know this is one of the later models because of the firewall was in front of it, the sniffer tube and the PCB with the electronic ignition. So this could be right at the end of 2002, but obviously not too sure. But the other Baxis behind me, they actually do tell us accurately when they were made. So let's find out when these were made then. Now, in 2003, Baxi changed their coding system. So you can see here is an example of how they do it now. So the ABC that you see at the beginning is the product code. The next two numbers you see, which is 06 here, is the year of manufacture. And then you see the 10 in box 3. That is the week it was manufactured. And you can see 4 is the appliance number within the week of manufacture, and 5 is the place of manufacture. So that's how Baxi now do their labelling system. Now, this Baxi Netatec Combi, there is a serial number here left on the registration sticker, which was never removed, but if we lift the flap here, it's also here as well. So this one, from the actual data badge, it was made in 2014 in week 21. That's how accurate these data badges are with this now. So that's how old this Netatec is. Now, this Baxi main combi was actually manufactured in 2007 on week 24, because the data badge tells us here. This Baxi Duotech, if we take the flap down, the serial number is here, and this was manufactured in 2011, week 4. And finally, the newest version we've got, this Baxi 600, which was made in 2017, week 35. Now I think these boilers were launched in 2017, so this is one of the older models. That's possibly why it is a display one. So that's how you date the Baxi boilers. Now if you've seen any of my inside a boiler casing videos, you've seen I start at the top of the boiler and work our way down. And that's pretty much what we're going to do here, because we're going to look at the flue systems. Now the Baxi Bermuda is what we call an open flued appliance. So that flue system was a stainless steel flue liner which went up the chimney. It's an open flued appliance, so it gets its air from combustion from within the room. So it needed a lot of servicing and a lot of looking after, and you definitely couldn't block those vents up. So if you do have a Baxi Bermuda still, or any open flued appliance, don't block those air vents. But these ones here are all room sealed appliances. Now if you can remember, this is my oldest boiler from 2007, and this is the flue system which I got for this boiler. But this is pretty much still the same elbow and flue system that Baxi use today. So shall we try it? Fits perfectly on the 2014 model. Fits perfectly on the 2007 model. Fits perfectly on this 2011 model. And fits perfectly on the 2017 model, which is the up-to-date model. But you can also see this is central, this is offset, this is pretty central, and that's offset. So the flues are slightly offsetted, even though they can use the same flue system. So that's the top of the turrets and how Baxi have kind of kept the same. And you can even see they've all got the same test points for flue gas analysing, because our oldest model is 2007 and condensing came out in 2005, so earlier boilers possibly wouldn't have the test points for doing the flue gas analyzer readings. So that's the progressions of the flues. Shall we have a look at the heat exchangers connected to these flues? Now, to check these heat exchangers out, we've had to remove the front covers. So you can see these two end ones here. So like we say, this is a 2014 model and this is a 2017 model. They're actually using the outer casings as the covers for the combustion chamber. So these are really important, and these boilers are not a million miles away from each other in size, are they? They look pretty much the same kind of style. If we look at the two middle ones, remember this is our oldest one of 2007 and this is 2011, they've got an inner combustion chamber, so the front cover is not part of the combustion chamber. We need to remove these two screws, and again you can see these two are very much alike in the way they're laid out, okay, but the difference is inside. If I open this one up to opening this one up, now you can see the major differences. This is actually an atmospheric burner, whereas the other three you can see are pre-mixed burners. So this one, the gas is burning upwards under atmospheric conditions, whereas these three are burning horizontally 360 degrees around the heat exchanger. Now they are all condensing boilers, but these three are what we class as a band A condensing boiler, whereas this one is a band B condensing boiler. So basically what Baxi did to get into the energy efficiency right at the very beginning, they turned their band C boilers into band B ones by using a secondary heat exchanger, which used the excess flue gases to preheat the water coming back in to the boiler itself. So that made them efficient. Well, a little bit more efficient than the band C. But you can see the progression of the burners are not a million miles away from each other in the other three boilers. Bearing in mind, this one and this one is a few years apart, but they're pretty much exactly the same heat exchanger. Just slightly different on the way they bring the products in. Bearing in mind, this is the brand new boiler. The 600, 800 is the same heat exchanger. So the heat exchangers are stainless steel heat exchangers, whereas the heat exchanger in here is copper. So let's have a closer look inside them. Now I've actually removed this burner from the boiler, the Duotech. You can see the heat exchangers are very, very different. You can also see this has had a bit of a problem. It's the first time I've ever opened this boiler. It's actually looks like its condensate trap is frozen because there's been a water tide mark in there. So anyway, let's have a close look at the burners first. So you can see this one burns 360 degrees around. So it's got flame rectification and the spark electrode. And the fan is connected to the burner itself, where the fan sucks in the gas and the air at the same time, shoves it out here, the electrode ignites it, it burns 360 degrees. And if we look at the heat exchanger, the water is all around the burner and it can gain all that excess heat. But if we have a look at the atmospheric burner, you can see there's quite a big gap between the burner and the heat exchanger, and the fan now is at the hot part of the boiler at the top. So if you look at these, the fan is in the cool part of the boiler, where the fan here is in the hot part. So the hot gases are going through the copper heat exchanger. The fan then is pushing the products of combustion through the secondary heat exchanger and then out through the flue. Whereas that one's burning 360 degrees, throwing it all the way around the heat exchanger, collecting at the back and then throwing it out. So all the heat is collected out of there, or a lot of the heat is collected out of there, but there's not a lot of heat collected out of that one. So the exit flue temperature of that one, 50-55 degrees. This one, about 155 degrees. So there's about 100 degrees difference coming out of there. But when they put this secondary heat exchanger on, that did then start to bring down the flue temperatures at startup to about 50-60 degrees, but once it had been running and it's not taking a lot of the heat back out, then it was just showing the heat back out. So on startup it was good, but then that was about it. Whereas on that one it continues with reducing the speed of the fan and modulating. Again, these are modulating burners, but they're just going up and down, where that one it's all about the speed of the fan. So this one is all worked off the gas valve, where this one is worked off the speed of the fan. Now I brought back the Baxi Bermuda and taken the front cover off so you can see the burner and the heat exchanger in this boiler. But the keen-eyed of you will be noticing that this is a different boiler. I picked the wrong one. I've got two of them here and I picked the wrong one. So this is actually the 50/40, different one. Shh, don't tell anybody. So this is the one with the PCB and the one with the electronic ignition. Not the one I brought up first because I just picked the wrong one up. But you can see this has got the sniffer tube going down to the oxy pilot, so if it got vitiated in the hood, so there was lack of oxygen in the hood here, because the vents have been blocked, then it would knock the pilot out and would knock the burner out. So that was the idea of the sniffer tube. So we can see again that this is an atmospheric burner. So it's burning up here. Pretty much similar to this one here, where this was the atmospheric burner. And you can see now we've got this big, huge heat exchanger. Now, big difference between the heat exchanger here and here is this heat exchanger is made of copper, whereas this heat exchanger, cast iron. So this is what we would call a low water content boiler, and this one we'd say is a high water content. And if you've ever heard the word kettling, these were the heat exchangers that kettled. So when they got full of crud and sludge and muck, they would make this kettling noise. So what would happen is the gas would be ignited, it would burn upwards, go through the heat exchanger, and inside this boiler we've got some baffles which try and keep some of the heat in there. It would then come through to the hood. Now this is where the fire spigot would fit on the front as well, and where the air would come in to help dilute the products of combustion. Air for combustion comes in here from the front. So the products of combustion hit this plate, which is your draft diverter, and then the products of combustion then would go up your flue liner, your stainless steel flue liner, and then up through your chimney. So these were hidden behind a fancy fire at the front. Well, some of them were nice, some of them were bloody awful. And it made the boiler disappear. You could just see the fire on the front. So they were a good invention. They tried to bring out a condensing boiler version as well, but it didn't last very long. But anyway, that's your Baxi Bermuda. Like I say, they put the PCB on it to try and make it a little bit more efficient, to make it last longer. And like I say again, I fitted quite a lot of these boilers. They were a doddle to service, doddle to strip. These boilers, you knew when you took them apart, they'd go back together again. These, you're kind of guessing, aren't you? Because it depends on who stripped it before you. But these, bulletproof, were brilliant. Okay. Biggest downside though is efficiency, and that's why these had to go. They weren't very efficient. So if you've got one of these boilers, yes, they were great boilers in the time, but you're probably looking at it being about 40 to 50% efficient by now. And if it is making the kettling noise, it's even less efficient. So these really should all be gone now, because they're open flued, they draw their air for combustion from within the house, so you've got a big drafty vent, which most people block, where these now are all room sealed and very high efficient. So that's the Baxi Bermuda back boiler, burner and heat exchanger. So that's how the burners and the heat exchangers have changed in really such a short space of time. Remember 2005 these first came out, 2006, and we're still using these heat exchangers now. Obviously the next progression is hydrogen, and hopefully we'll one day do a video on the new hydrogen boilers. So that's how the heat exchangers and burners have changed with the fan position. Let's have a look at the water set, or the hydro blocks at the bottom. First thing about the water set for this one, don't have one. This is a heat only boiler or a regular boiler. These are combi boilers. So combi boilers have filling loops, expansion vessels, pumps, diverter valves, all these different components installed inside them. This is just basically a way of heating the water. So for this one we would need a cylinder, we would need an external pump, we would need zone valves, we would need an F&E system, or we would pressurise the system using an external expansion vessel, filling loop and gauge. So don't have a water set this one, but these ones do. Now if we look at the actual water sets of these boilers, there's been some quite significant changes. If we look at this oldest boiler, we have a brass hydro block, but we have a diaphragm here working for the hot water, so it works off differential pressure. The other boilers are working off flow turbines. So these have all got flow turbines, slightly different flow turbines, but they've still got flow turbines to make a diverter valve work rather than a diaphragm operating from the flow of the water, differential pressures. The other major difference is this one's got a plastic hydroblock where all the rest of them are brass hydroblocks. So they're the first things you notice when you open or drop the flaps from the boilers. Now the next thing I notice is pumps. Now in 2015 boiler manufacturers had to start installing ERP pumps, so energy rated products ERP. So basically the pumps had to modulate. So because this one is a 2017 model, it's got an ERP pump in. Now the next youngest one is this model, which is a 2014, but it doesn't have an ERP pump in it. So obviously these two don't have ERP pumps in. So that's the first difference on the pump as well. ERP modulated pump, fixed speed pumps. Okay, 1, 2 or 3 speed pumps. So let's have a bit of a dive in now and look at these different hydroblocks closely. So let's start with the old Baxi main boiler. So let's start with the condensate trap. So you can see the condensate trap is there. And they use a sensor in the condensate trap to say if it was blocked, to turn the burner off. It turns the ignition off. You can see the pressure relief valve there, and we can see the pump. You can now see the gas valve. At the back there is the plate heat exchanger, and then you can see the diverter valve works off differential pressure, no flow turbine. So that's the oldest one, the Baxi main. Then the next oldest one is this Duotech, so you can see the changes here. The condensate trap now is right at the back, not easy to get at. We've got the blow off or the discharge PRV down at the bottom there. You can now see the pump. You can see the gas valve looks similar to the old one, but it's not, it's a sit valve. And then you can see the big difference in the hydroblock. So we've now got at the back there, you can just see it, the flow turbine, and it's operating the diverter valve through this motor here. So this is the Netatec boiler, which a lot of engineers say is Baxi's worst boiler. But this side now we've got the condensate trap and the blow off. On this side we've got the diverter valve head and the pump. And then the gas valve is different, completely different. And you can see it is all plastic in there. So a lot of engineers are not happy with this boiler. And then finally, we've got the 600, the newest boiler here. So again, you can see the PRV is dead easy to get at. You can see, again, the flow turbine at the back there. You can see the diverter valve and the motor is still on this side. Condensate trap is a lot bigger and a lot better, easier to get at. And the pump is your ERP pump. So that's what they look like closely inside. All working with plate-to-plate heat exchangers to heat up the hot water. Let's have a look at the expansion vessels, because all these boilers would be pressurised. They're not open vented. Okay, so we would be pressurising these to between 1 and 1.5 bar when they're cold. So the expansion vessel is incredibly important when these boilers are working, and they can break on a regular basis, but they need to be also checked on every service. So if we start at the old one here, oh, where's the expansion vessel? It's on the back of it. A lot of boiler manufacturers always put their expansion vessel on the back because they're quite a big thing and they didn't have the space, as you could see, which makes it now difficult to test them, difficult to replace them. So if you do go to a boiler and you see the expansion vessel separately on the return just near the boiler, you know, because the expansion vessel's gone on the back and the engineer couldn't be bothered taking it off the wall. But you can see all the others, they've got their expansion vessels where they're incredibly easy to get at. This one, they've even put the Schrader valve, so the new 600, the Schrader valve is at the top. So that's mega easy to get at. This one is pretty difficult to get to, and you have to take this off. So this is the spark generator, and you've got to take this spark generator off to be able to get at the Schrader valve, because it's right at the top here. Obviously this one's at the back, so even harder. And this one is at the bottom here. So quite easy to get to. So they can't get it at the top, so they put it at the bottom. So that's how you get to the Schrader valves on the expansion vessels. So you can see we've had a big progression from the expansion vessels from this being on the back to this one where they're incredibly easy to get at and incredibly easy to change. Now this little beauty didn't need expansion vessel because it's open vented, like we say. So the open vent and the F&E system, or the feed and expansion system. So the open vent is a safety device, the F&E is the feed and expansion, that puts the water in and takes up the expansion of the water. So it doesn't need a pressure relief valve and doesn't need an expansion vessel. And it doesn't need a filler loop because the feed and expansion puts the water into the system. So that's the back boiler. Now let's finish off now and have a look at the pipe configuration down below. We might as well start with this one. This is what we called a 3-piper because we had 2 flows and 1 combined return. So we had an injector T down here bringing the return pipes in. So the one coming straight in would be the central heating return, and the one dipping underneath would be where the gravity hot water return would come in. So either one of these would be your gravity hot water and your pump central heating. If you turned it into a fully pumped system, then you would still need your T, injector T, bringing back your 2 returns. So for this one, we basically had 3 pipes coming off it. A flow for the cylinder, a flow for the central heating, and a return going back from both of them. The other good thing about this is, if I spin it around, you can see these 3 ports are blocked off. But, if I put it square on again, this heat exchanger can be spun over. So the pipe connections will come to this side. So if you want it to go on the left hand side of your chimney opening, you spun the heat exchanger around that way, and if you want the right hand side, then you have your connections on this side. So that's the pipe configurations. It's what we called a 3-piper when we worked at the council. The glowworm version had 4 pipes, but this one just the 3. Technically 3 connections, 4 pipes. Let's have a look under the combis. Now the pipe configurations on all these boilers are laid out pretty much the same. Now these 2 boilers are actually installed on the same jig. Well, if this was the Baxi version instead of the main version, it would actually be on the same jig. This one just has this bracket. So this allowed you to pre-pipe up the pipework first before you put the boiler on to the jig onto the bracket. And if your pipework or your wall wasn't completely straight, this gas connection was a bit of a pain to get on. It was an offset elbow and it was a bit, yeah, if you've ever fitted one of these boilers you'll know what I mean. So this boiler and this one all come with a jig. Now the new boiler, the 600, the 800 or the main eco, whatever it's called, you get just a bracket, but you also get a pipe bracket as well, because the 600 and the 800 you could pipe up the back of the boiler. These you couldn't pipe up the back of the boiler unless you get your standoff jig, but I don't really remember them having a standoff jig. But anyway, yeah, so that one you can pipe up the back. These had a jig like this, or these have got a jig like this where you can pre-pipe them up, but they're all laid out pretty much the same. So if we have a look under this one, we're going to see exactly what I mean. So if we start on this side here on the left hand side, you can see we've got the condensate trap. Then this one is the blow off, or the safety discharge. The one you can see around the back here is the flow. That's the hot water, that's the gas, that's the cold water, and that one's the return. And you can see on this one we have Baxi's filling loop, which has not changed much. But under here you can see the pressure gauge is under here. So instead of putting it on the front, they put it underneath there, which is good for when you're filling it up, but not if you're a customer. Anyway, that's on the Netatech. So this is the main combi HE. That is the flow. Then we've got the hot. Then we've got the gas. Then we've got the cold. And then you can see we've got the return. And this at the front here now is the blow off. These, what you can see here, are where the filters are. So there's filters inside here, but you could also put the filling loop on these two. The same filling loop as what is here. So this is the Duotech, and you can see it's laid out the same, but our condensate pipe is at the back here. This is our flow, hot, gas, cold, return, with our filling loop, with the discharge pipe up here, which is still on the same side as this one. So finally, let's have a look at the new 600. Now the 600 is laid out pretty much the same. There's our flow, there's our condensate, hot, gas, cold, and return with the new filling loop. So you can see that the pipe configurations have all pretty much stayed in the same orientation and all in the same location. So that's underneath the Baxi boilers and how their pipe configurations have changed. Now that is the end of this video on what's inside a boiler. So if you've liked this video, why don't you give me that thumbs up or leave a constructive comment down below. If you've not subscribed to my channel, then please subscribe because it helps. And don't forget to hit that notification bell because you want YouTube to tell you when we're uploading videos. I'm sure you know by now it's Mondays and Wednesdays. So all I've got left to say is, thanks for listening, thanks for watching, and I'll catch you on the next one, guys. Cheers.